from a research standpoint comes from the NIH and NIAID. As you know, we're part of the Department of Health and Human Services, as is the Centers for Disease Control and Prevention, who also have a considerable amount of contributions, both from a public health surveillance as well as from a research standpoint, in the topic for today, which is gain-of-function research on highly pathogenic avian influenza H5N1. Infections of humans, i.e. jumping species, is rare, but when it occurs and causes severe respiratory illness. Currently, this virus is not well adapted for sustained human-to-human transmission, but there is concern that has been going on now for approximately a decade. In fact, the first cases were in 1997, but since 2003, there has been considerable concern that the virus may ultimately acquire the ability to adapt itself better for human-to-human transmission. And integral to that study has always been the issue of gain-of-function research, not only for influenza, but essentially for all infectious diseases research. Now, there are a few ways to look at gain-of-function research. There's the naturally occurring mutations which naturally give gain of function, and investigators study these effects on the phenotypes of interest. Does this mutation make something more transmissible, more pathogenic, or adapt to host better? Or, what historically investigators have done is to actually create gain of function by making mutations, passage adaptation, or other newer genetic techniques such as reverse genetics and genetic reassortment. When we do that, often some phenotypes appear and others disappear. For example, it is commonly seen that when you increase a transmissibility, you may see a decrease in pathogenesis, or vice versa. You may deliberately increase pathogenesis and see a decrease in transmissibility. But the bottom line is that gain and loss of function research is critical to understanding disease pathogenesis, antimicrobial resistance, and host responses, as well as to developing better techniques of surveillance, vaccines, and therapeutics. Specifically, to gain-of-function research on HPAI H5N1. What we're talking about now is the gain-of-function research in studies that increase predominantly the transmissibility, as is the case that I'm going to get into in a moment, as well as pathogenesis and alteration of host range of the virus. There were studies done by two NIH, NIAID-funded investigators, Ron Fauci and Yoshi Kawaoka, in which H5N1, a strain from Indonesia and a strain from Vietnam, were altered in a gain of function, either by direct mutation or by reassortment. And by passage in ferrets, the mammal model for this virus, for humans, there was an increase in fact, a development of aerosol transmissibility in a mammal which this particular virus did not have.